Hey guys, on this video we're going to take a look at how to convert the recurring decimals into what? Into fractions, So on this video we're going to take a look at how to turn a recurring decimal like this into fraction, and also this one. So if you watch this video up until the end, you're going to know how to turn all this into fractions. So first, let me just give you some background information that you need to know. What are the recurring decimal? You might be asking yourself. So the recurring decimal, guys, you will understand it better if you first understand what is happening here. So there are fractions like 1 over 2, which you probably know that this is 0.5. The decimals like 2 over 5, which is 0.4. For example, I'm just giving an example. 1 over 25, which is 0.04. So these are what we call the terminate decimals. Decimals. I'm talking about these decimals that are here. We call it the terminating decimals. Why do we call them the terminating decimals? It's because they stop somewhere, They don't go forever, they stop somewhere. For example, it's 0.5 where it does not go anywhere. Meanwhile, when we talk about when we talk about the recurring decimal, we talk about those kinds of decimal that never stop. For example, a number like 1 over 3, this number, if you put it in a calculator, you're going to get 0.33333. It never stops, it keeps on continuing. A number like, for example, 25 over 99 is the same as 0.252525. It never stops, it keeps on continuing. Another one, 456 divided by 999. This one, it's 0.456456. It never stops, it keeps on continuing, So these are the recurring decimals that we are talking about here, that never stop. However, it's not all those kinds of decimals that never stop that are recurring. For example, there is a number like, I'm just giving an example, there's a fraction like the root, let me just use a different card. There's a fraction like root 2 over 2, Root 2 over 2 is a fraction like 0.70716. If you put it in a calculator, you're going to get this number that never ends, So these type of decimals that are here, this one, are not a recurring decimal. And you might be asking yourself, Gridwell, why? You just said to us that the recurring decimals are the one that never stops. But now you're saying this one is not a recurring decimal, but it also not stopping. Yes, I did say that, but I didn't mention this one thing that you need to understand. So on the recurring decimals, this one, the recurring decimals, they have pattern with them, You can see that this is 3, is going to be 3 and 3. Like we can predict that the next number is going to be 3, is going to be 3, Yes, it has the repeating numbers, but you can predict what will be the next number, And also if you come to this one, it's 25, 25, 25. You can predict that this is going to be 25 there, And also this one, is 456, 456. You can predict here there's going to be 456. It means that the recurring decimals, they're not just like they don't just like never end. It also have a pattern with them that you can be able to predict in future. Meanwhile, the decimal like this one, yes, it does not stop, but you cannot predict what will be the next number, Yes, there are some repeating numbers like 777, but the pattern, you cannot predict what will be the number, because there is 707. We cannot predict, there's no pattern for this type of numbers. So these are the irrational numbers. So all the recurring numbers, guys, are what are rational. Why? Is because they have that kind of pattern that there's a pattern on their decimals actually. Perfect. So this is what we're talking about when we talk about the recurring decimals. So what is something that you need to know about this type of recurring decimal? Something that you need to know is that this 0.33 mathematically we can be able to represent it as 0.3, and we put this type of stuff, So the number that repeats here is the one that they put something there at the top. And the one that repeats here, for example, this is 0.25, it's going to be 0.25, and they put that kind of dot there at the top. And also for this one, there are 3 numbers that repeat here. It's going to be 0.2, not 2, 4, 5, 6, which it has this kind of a stuff, So what we want to know right now on this video specifically, we're going to know how to turn this, into this kind of fraction, and how to turn this into this type of fraction. I'm sorry I gave a lot of background, but I just wanted you to understand, So now we're going to do these examples. I'm going to create some space so that I can be able to do them one by one. So here's the first one, 0.7. So you probably by now, you understand that 0.7, that is a recurring thing here. This is the same as 0.7777. This thing that is here, it means that it repeats. The 7 is the number that repeats over and over until infinity, So what we're going to do to turn this into a fraction is just going to use the x method. We're going to say x be equals to this type of number. So what we're going to do next is to try to multiply out this number either by 10 or by 100 or by 1000, And a lot of my students are always confused. Which number do we multiply it with here? Which one is always correct when we multiply it with this number in order for us to create the second equation? Here's a little bit trick that you need to know. So when you have a recurring decimal like 0.7 or 0.8, which is a recurring, or 0.5, which is a recurring, you always multiply this type of numbers by 10, And when you have a recurring decimal like 2/5 or 0.19, like this 0.69, I'm just giving an example. This you multiply by 100. When there's two decimals of the recurring things, you multiply by 100, And then when there is 1, 2, 3, I'm just giving an example, you're going to multiply by 1000. Depending, if the numbers are 3, you're going to multiply by 1000 is 200, Keep that in mind always. It does not change. It's always the same thing over and over and over again, So now we're just going to just do this one. So on this one, I'm not going to waste time. So here we're going to multiply by 10. So we're going to multiply this by 10. Going to say 10x, which we're going to take this number, punch it in a calculator, and see the number you're going to get. Multiply this by 10, You multiply both sides by 10. You multiply here by 10, you also multiply here by 10. So when you multiply this by 10, you're going to get 10x. When you multiply this by 10, you're going to get 7,77777, and that never stops. So this we're going to name it equation 2. This will be equation 1. So what we're going to do next is to take equation 2, the bigger one. You take equation 2 and you subtract it with equation 1. The equation 2, it says 10x, which we're going to minus with this one that is there. We're going to minus it with x, which is going to be equal to. And then 10x, what does 10x equal to? Is equals to this number that is there. So I'm going to write it there, which is 7,777. I'm not going to write all of them. There are a lot, I'm just going to end it here. So going to minus with what? With this x. What does x equal to? Is equals to this number, which is there in the red, is 0,777. So I'm just going to put it 3 up there, So if you work this one out in your calculator, this is going to give you 9x. And this, if you work this one out in a calculator, no matter how many numbers that are going to get, but they're going to get 7 if you punch it on a calculator. No matter if you put the same numbers here, if you put 4 numbers, you also have to put 4 numbers there. So I'm going to divide both sides by 9, divide both sides by 9. Then our x is going to be equals to 7 over what? Over 9, 7, which is this one. It can also be written as a fraction of 7 over 9. So this is how to convert this. Let's just try the next example. So the next example is turning this recurring number into a fraction, So here we have 0.95, which they have the recurring numbers there at the top. So what do? We're just going to, we know that if it is as a recurring number like this, it's going to be 0.9595, which is keeps on repeating until and until, So I'm going to use that our x method, which is equals to this one. Remember, when we have 2 digits, which number do we multiply with? We're going to multiply by 100 both sides, So we're going to multiply this by 100. If you multiply this one by 100, you're going to get 95,9595, perfect. So what we're going to do, I'm going to name this equation 2, this equation 1, and then I'm going to take the bigger one and separate it with the smaller one. Equation 2 minus equation 1, So we're going to take equation 2, which is 100 minus x minus x, And I'm going to do the same thing. I'm going to take this equation, which is 95,9595, which I'm going to minus it with this, which is 0,9595, you know. So if you work this one out in a calculator, we're going to get 99x. On this one, I'm going to get, if you work this one out by calculator, we're going to get 95, you know. So this is going to divide both sides by 99 and 99. And then our x is going to be equals to 95 divided by 99. You know, so in other words, 0,95, which is the recurring decimal, it can be written as a fraction of 95 over 99. Let's do one more example. So our last example is this one. I'm going to try to turn this into a fraction. How can we do that? We know that if it has this kind of dots, there's a recurring decimal which is the same as 0,123, 123, 123, until number 2 does not end, you know. So we're going to let it be equal to x, and then we're going to create another equation. When the decimals is 3, we're going to multiply by what? By 1,000 both sides, you know. If it was 2, we're going to multiply by what? By 100. If it is 1, 10, you know. So we're going to say 1,000, x, which is equal to what? We multiply this number by 1,000. We're going to get 123, 123, 123, until there. So I'm going to name this one equation 1, equation 2, this one equation 2. So then I'm going to take equation 2, we subtract it with equation 1. Now we're going to take what? Let me just erase this one. So now what are we going to do? We're going to take this equation 2 and subtract it with equation 1. So we're going to say 1,000 x, we're going to minus it with what? With the value of x there. And then right now we're going to take the value of what does 1,000 equal to, is equals to this, which is 1,23, 123, 123, which are going to subtract it with this one, which is 0,123, 123. You know, yeah, those kinds of numbers are there. So here we're going to get 9,099 actually, you know. So here we're going to get, if you subtract this by your calculator, you're going to get 123, then divide both sides by 99, and then 99, then the value of x is going to be equals to 123,999. So this is how to convert the recurring decimals into fractions.